Hello everybody, welcome to the first video of complete VHDL series. In this series, we will be learning VHDL programming, and in this video, we are going to answer one simple question. What exactly is VHDL and why should you care about it? VHDL stands for Very High Speed Integrated Circuit Hardware Description Language. That is a long name, so let us break down what it actually means. VHDL is a language used to describe how digital hardware behave, not to write software, not to build app, but to design and model actual circuit before anyone manufactures a single chip. Think of it like an architectural blueprint. An architect draws a building before any bricks are laid. VHDL lets hardware designer design a circuit before any silicon is produced. That one idea describing hardware before building it is the foundation of everything in this series. So, why does VHDL exist in the first place? Modern digital systems are incredibly complex. A single processor chip can contain billions of transistors. Designing that directly in hardware without any verification would be extremely expensive and almost guaranteed to fail. VHDL solves this by letting designers model their circuit digitally, simulate how it behaves, catch errors early, and only then move to physical manufacturing. This is used across major industries: FPGA design, ASIC development, embedded hardware system, all of them rely on VHDL as a core part of their workflow. Now, here is where many beginners get confused. This is important, so pay close attention. If you have written code in C, Java or Python, you are already used to software thinking. Your code runs one line at a time, step by step, on a processor. VHDL is fundamentally different. In VHDL, things do not happen one after another. They happen simultaneously. Because in real hardware, multiple signals and components are active at the exact same time. You are not writing instruction for a processor to follow. You are describing the structure and behavior of a circuit. This shift in thinking from sequential software to parallel hardware is the most important mental adjustment you will make in this series. Once you get it, everything else becomes much clearer. Let us talk about what VHDL actually lets you build. At the simplest level, you can describe basic logic gates, and or not. From there, you can move to combinational circuit like multiplexer, decoder and adders. Then some sequential circuit, flip-flop, counter, register. These are circuits that have memory and respond to clock signal. And at the most advanced level, VHDL can describe complete digital systems like CPU architecture, communication modules, digital controllers. In real-world applications, this maps directly to FPGA-based systems, signal processing hardware, and embedded control systems. VHDL scales from a simple 2-input gate all the way to a fully functional digital system. That is the power of this language. Let us quickly look at where VHDL sits in the real hardware design workflow. It starts with a design specification, what the system needs to do. Then comes the VHDL coding phase, where the behavior is described in code. After that, the design goes through simulation and verification. This is where you test it digitally and catch bugs. This synthesis converts your VHDL into actual hardware logic. And finally, the design is implemented on an FPGA or manufactured as an ASIC. The tools you will hear about most often are ModelSim for simulation, Xilinx Vivado, or Intel Quartus for synthesis and FPGA implementation. VHDL sits right at the core of this entire pipeline. It is a language that connects your design ideas to real hardware. So what will you be able to do by the end of this series? You will write clean VHDL code from scratch. You will design both combinational and sequential circuits. You will build finite state machines. You will create and run test benches to verify your design. You will understand the full FPGA implementation flow, and you will complete real digital design projects. This series is structured to take you from the fundamentals step by step all the way to industry-ready digital design skills. So before we wrap up, let us do a quick knowledge check. Pause the video and try to answer these on your own. Question 1. What does VHDL stand for? Question 2. Is VHDL a software programming language or a hardware description language? Question 3. Name two industries where VHDL is commonly used. Question 4. What is the key difference between how software executes and how VHDL models behavior? And question 5. Why is VHDL used before building real hardware? Take a moment and answer this on your own. We have discussed all these concepts throughout this video. And that is it for video 1. Now you have a clear picture of what VHDL is, why it exists, and where it fits in the real world. If you like this video, please subscribe to the channel and follow the complete VHDL playlist here.